Hi children, I hope you have revised the previous lesson that I taught you about the basics of electrochemistry, and this is the continuation of that lesson, and we go a little further, deeper into this lesson, the technical things. Okay, in the first video lesson you have studied, and just let me complete this, and sulfuric acid is simply the reaction, how a chemical reaction happens between the sulfuric acid and magnesium or any metal that is above hydrogen in the activity series. Okay, now you have studied, right? The very important thing is the magnesium gives the electron, H plus obtain that electrons, but the distance between the electrons and the H plus is very short, so it is useless. And you have studied, I think, I just let me remind you a lesson from history. One of our ancient king, that may be Parakramabahu, he has said that I don't even waste even a drop of water that is flowing into this country. Right? That means he said, right, without using that water, he never let it go to the sea. For example, you can see this is the hill country and water is flowing towards the lower parts and finally it goes to the sea. And what we can do is, if you don't do anything, just the biggest resource, the fresh water, just flow along the lower land and finally go into the sea. But if you want to use them, the ancient kings, and they have done and constructed dams in different sizes along the river, and they have stopped the water and distribute in lateral sides, bilateral and both sides of that river, and in order to the cultivation, and they get use of that water. So here, so what is happening, the lesson that we have to learn from science or from the nature, from the history is this. So simply the water is flowing, and if you let them to go, they will go and it will become useless. But if you want to use, and we have to do some work in between that, in the middle of that things. And here also same. And you have studied from the earlier classes, lower classes, the movement of electrons from one place to another place is called electricity. So electricity is very important, the energy, form of energy. It's a secondary form of energy that we have studied, that is, we cannot get it naturally, we have to get it from by converting another form of energy into electricity. But these days, almost all the things are being operated by electricity. So electricity is very important form of energy. So why do we want to waste that energy from electrons, and we have to use that energy of electrons? By simple work we can do that. How can we do this? Right? I told you earlier, the distance between H plus ions and electrons are very short. So what will happen? Just the very close, and H plus ions can get electrons, and it is being useless. That's we can produce only hydrogen gas. Otherwise, it is useless. Right? Okay. So now what I am going to do is, I am going to separate the electrons and H plus ions, let them wait for a while, let the H plus ions to wait for a while until they obtain electrons. And during that time, I want to let the electrons to move from one place to another place. So now you can understand what can I do. I can produce electricity from these chemical reactions. This is the ultimate thing of electrochemical cells. So how can I let the electrons to move from one place to another place? I told you here, listen to me clearly, H plus ions are here, and in the presence of H plus ions, and magnesium will release 2 electrons, and it will become magnesium 2 plus ion. Magnesium 2 plus, Mg2 plus ions go into the solution, but electrons will accumulate here. So if I give a place, a road, a pathway to go, and they will move. Now you know that electrons cannot go this way. Electrons can travel very clearly through the conductors. So magnesium is a metal, it's a conductor. So better conductor is copper wires. I add copper wire, and in order to show you the electricity is flowing, then I can fix a bulb to make it as a visible evidence and bring here, and I can add another metal. So I have divided. So what will happen? The magnesium 2 plus ions go into the solution. The same time electrons. Here no electrons. Here more electrons. This is the beauty of nature. I always tell you, right? Whatever more in one place, they tend to move to the place where the thing is less. Here no electrons. Here more electrons. So electrons from this magnesium plate go to this plate, and this will be better. I can take this as copper. I will tell you the reason why I have selected copper for this purpose. Now what will happen? Earlier, so while only the magnesium plate was here, and magnesium 2 plus go into this, and it will become negative charge. That's very important. So because of the accumulation of electrons, this plate will become negatively charged, and positively charged hydrogen plus ions come closer and get the electrons. Now what will happen? This is negatively charged one, and relatively it does not have any negative charges. So this will become positive, and this is negative terminals, and electrons from the magnesium plate to copper plate, it is flowing. Electrons are flowing from magnesium plate to copper plate. The flow of electrons is called as electricity, and you can see the witness. The bulb will light up. Or instead of this bulb, you can use a galvanometer. You can see the deflection, or ammeter or milliammeter. So any device that can show you the flow of electrons or the electricity. Right. So now this is the beauty. You can see now we are getting into the lesson. You see there are two plates I have used here. These two plates are called as electrodes. Here in this diagram I have made electrochemical cell. So we call this electrochemical cell. There are certain parts of electrochemical cell. You can see I have fixed two metal plates. That is very important. Two different metal plates. It should be two different metal plates. You can't use magnesium and magnesium. You can't use copper and copper. So there should be two different metal plates, and dipped into a liquid or aqueous solution of electrolyte. There are two components. One is electrode, the metal plates that we are dipping into the sulfuric acid, that is called electrode, and the liquid, the sulfuric acid, the usual one is sulfuric acid or aqueous solution, and that is called as electrolyte. Here I can write it for you. This is an electrode, and this is the another electrode, and this is electrolyte. So names are very clear. So this is these two electrodes and one electrolyte, and electrodes are dipped into the electrolyte, and two electrodes are connected by copper wires. You can see here it is being connected by copper wire. So copper wire is a very good conductor with less resistance, so that is more suitable to use copper wire. And here you can see a galvanometer. A galvanometer to indicate two things. One is the amount of electricity, and the second one is direction of electricity. Both things can be indicated by a galvanometer rather than a ammeter. And here these are the parts of electrochemical cells. First one is two electrodes. I told you earlier, you cannot use both electrode as the same metal, right? If you use same metal as two different electrodes, the electrochemical cell does not work. If you want to get it work, and you have to use two different metals, and one should be higher reactive metal, the other one should be relatively lower reactive metal, then only this electrochemical cell will work. But here you can see here clearly. So the magnesium, during this setup you can see certain observations, you can see certain things, we call them observations, and you can see the magnesium is reacting with sulfuric acid, so the magnesium will dissolve. So this plate will dissolve, right, disappear, right, with the time the size of the magnesium plate will reduce. The second one, the electrons are moving here, the copper plate is supplying the electrons to the H plus ions. Now, so if I don't keep a copper plate here, and you can see it will dissolve, and at the same time around this magnesium plate you can see gas bubbles. The gas is hydrogen gas, and you know that the gas will evolve in the same plate. But if I add a copper, what will happen? Now this is dissolving, this is reacting, the same time electrons are coming to this terminal. Now this have extra electrons, wherever electrons and H plus ions will be attracted towards that, and now H plus ions go to this terminal and they will obtain the electrons and combine with each other, and they will make H2 gas. Now you can see the gas bubbles are evolving from this copper plate. I hope you are clear, and we do some more exercise to make this thing even more clear. After this lesson I will send you different assignments in different levels, and if you do them in a proper way, then you can get a more understanding. Okay, so now you clearly see this again. So one terminal is producing extra electrons, that terminal act as negative terminal, and the other terminal is relatively empty of electrons, so we call that positive terminal. In the negative terminal you can see, right, magnesium is releasing electrons. Releasing electrons is called as oxidation. So in the negative terminal oxidation happens. Come to the next point. Here in the positive terminal, right, H plus ions obtain the electrons in the plus positive terminal, so reduction happens in the positive terminal. Here reduction. So let me tell you a very important point, just listen to me very clearly, right? Keep your eyes and all the senses on this video and look at this, right? Wherever in an electrochemical cell, right? I have highlighted my word, in an electrochemical cell. Wherever oxidation happens, that place is called as anode. Wherever oxidation, releasing of electrons happens, that electrode is called as anode. Anode is negative in electrochemical cells, right? When you study electrolytic cells, things will be little different, but this is the same thing. Wherever oxidation happens, releasing of electron happens, that place is called as anode. Or wherever reduction happens, and that electrode is called as cathode. So I can tell this in another way, right? In anode, oxidation happens. In cathode, reduction happens. Oxidation happens in anode. So wherever oxidation happens, that electrode is called as anode. Anode, vice versa. You have to be able to think in all the possible ways. Right, listen to me carefully. Right, the place where oxidation happens, that electrode is called as anode. The place where reduction happens, that electrode is called as cathode. Right, keep in your mind, anode oxidation, cathode reduction. Now it's very important. If I give you an electrochemical cell, it's a complete diagram of an electrochemical cell, and your task, the first skill, ability you should develop, that is identify which electrode is anode and which electrode is cathode. That is very important, and you have to do that. That's what we are going to do the next step in that this lesson. So let me arrange my things for that thing. So here I will tell you, children, how you can identify anode and cathode in any chemical cells. And before that, I am stressing the before this lesson, just remind and be familiar with the activity series. I don't tell you to memorize by heart, and I am telling you to be familiar. In order to be familiar with anything, you have to use them frequently. Then you will be familiar with that, and things will be very easy for you. So this is the activity series in your syllabus, very short, and I think a few elements are here. And if you know this activity series, and you can learn things, and you can solve any problem related to electrochemical cells very easily. And I am telling you so kindly, right, if you see any questions from electrochemistry in your oral papers, please don't miss that. It is very easy to get marks, right? It is very easy challenge, and it takes less time, so you can manage and you can allocate more time for other chapters if you have it in your exam papers. Okay, let's have, and this is the thing, this is the order. Let me tell you: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, and gold. Or you can tell it in the symbols. Oh, the other thing is very important. I always stress it to my children, my students. Not only this one, you have to be very familiar and you have to be very clear. And I told you even in the previous lesson, previous video lesson, and these are metal except hydrogen, all the other things are metal. And you have studied in structure of metals, metallic elements always make positive ions, cations, plus ions, and non-metallic elements produce negative ions. They like to obtain electrons. Metals, they like to release the electrons. But according to the order, according to their group, and you must know what are the ions they will produce, and it will make your work even more easier in the problem solving work. Right, let me write it. Potassium always makes K plus ions, sodium make Na plus ions, calcium always make Ca 2 plus ions, magnesium Mg 2 plus ions, aluminium always 3 plus ions, Zn always make Zn 2 plus ions, Fe makes Fe 2 plus ions plus 3 plus ions, but you consider they have 2 plus ions, that is enough for your syllabus area. Sn makes Sn 2 plus and 4 plus, but 2 plus you consider as Pb 2 plus and 4 plus, and Cu always make 2 plus ions. The other ions are not important. These things are very important. So whenever, so children, if you know the activity series and the ions they are making in a proper way, what type of ions they are making, whether the positive ions or 2 plus ions or 3 plus ions, and you are ready to face any challenge in electrochemical cells. Okay, so you know the basics, you know how to find anode and cathode, and let me go for some technical things. Okay, let's consider the number one, first electrochemical cell. It is an electrochemical cell. You can see here it has two electrodes, one electrolyte, and both electrodes are connected by copper wire. In between you have a galvanometer. So this will work, right? So it is, very clear. All the components of electrochemical cell is completed here. So now the technical things. I will ask you, and out of zinc, one electrode is made up of zinc plate, the other electrode is made up of copper plate. So we have to think how this chemical reaction will happen, and which one will act as anode, which one will act as cathode, and which component will oxidize and which component will reduce. So if you understand these things clearly, and the second step, writing the equations, that will be easier for you. So I am telling you all the things in an order, thinking order. If you catch that and if you follow that, it will be very easy to solve any problem related to electrochemical cells. So listen to me. The first thing, if a electrochemical cell is given, first thing is you have to identify which electrode is anode and which electrode is cathode. The first easy work, and I told you, and what is the skill, the thing that you want to have, that's the skill I have written here, right? If electrochemical cell is given, and just close your eyes and just recall the activity series and write in a corner. That will be very useful for you. So let me take the components here, the two electrodes. Let me circle it, zinc and copper. Here where zinc, I have zinc here and copper is here. I told you, right, the metal in higher place in activity series will act as anode, in the lower place act as cathode. Here look at this, right? If you compare copper and zinc, zinc is the higher place, so zinc will act as anode. And if a zinc acts as anode, there is no doubt copper will act as cathode. This is the first thing we have right here. And I told you, anode, and what type of reaction will happen in anode is always oxidation. Oxidation happens in anode, reduction happens in cathode. Reduction happen in cathode. This is second step. And now you have to decide which will oxidized and which component will reduced. Let me write it here in this board, and it is very clear. Anode will oxidize, right? Whatever the element you are using as an anode, itself oxidize. If you use zinc, zinc will release electrons and it will become, think about that, zinc always produce 2 plus ions. If you use magnesium, magnesium itself will release electrons and it will become magnesium 2 plus. If you use aluminium as anode, the aluminium itself release electrons and produce Al3 plus. So now first I am going to write the oxidative half reaction here. Number one, oxidation half reaction. Half reaction means in this overall reaction both are happening, oxidation and reduction. I am going to write only one here, oxidation. Oxidation happens in anode. Anode is zinc. This is this next step, how to write oxidation. Zinc is solid here, and after releasing electrons, follow the order that I am writing here. Zinc is a metal and it is releasing electrons and producing zinc 2 plus ions, that is in the aqueous solution. Now I told you, whenever you balance the half reactions, you have to consider the number of atoms and the number of charges. You have to neutralize the charge always, and you can neutralize the positive charge by negative electrons, by adding negative electrons. Wherever the positive charge is there, the same side you have to add electrons. Here one zinc and one zinc. Here this side zinc 2 plus and this side no charge, neutral. So you have to neutralize this. Wherever positive charge is there, that side you have to add same number of electrons, 2 plus. So in order to neutralize, you have to add 2 electrons. This is equation number 1. Second equation, that is reduction half reaction. So let me think, right? You have to think with me. And okay, if the zinc is being oxidized, and who is ready to obtain the electrons, right? So I told you, whatever being used as a cathode does not participate in any chemical reaction. The work of a cathode in electrochemical cell is just to pass the electrons to the component which is obtaining electrons. So in any electrochemical reaction, electrochemical cell, we are using sulfuric acid, dilute sulfuric acid as a electrolyte. So it has H plus ions and SO4 2 minus ions. So you can decide, right, whether the negative ion or the positive ion is in need of electrons. Always, mostly, positive ions are in need of electrons. They have a vacant shell where we can fill the electrons. So now let's think what may happen. Always in electrochemical cells, always H plus ion will be reduced. You don't want to think about anything else. This is the only thing will be reduced. Here, H plus ions aqueous solution is, you know what will happen, right? In the copper plate you can observe the gas bubbles. The gas is hydrogen gas. Hydrogen gas means is a molecule H2 gas. Now look at this. I told you, whenever you want to balance a chemical reaction, half reaction, you have to think two things. One is the charge, the other one is number of atoms. First we go to the number of atoms, right? 2 hydrogen ions, here 1 hydrogen ions in order to make it 2. If you do it more times, it will be practiced and you will be familiar and no need of memorizing. So I am requesting you to don't memorize but make yourself familiar with this thing. Okay, now let's go to the charges here, right? 1H has 1 plus, so 2H have 2 plus. So this side entire thing is 2 plus. In order to neutralize, you have to add 2 electrons, and I told you wherever the side the plus ions are there, the same side you have to add electrons, 2 electrons. So this is the second equation. Now you can write the overall reaction. All these, the reactants one side and all the products the other side. But I told you very important thing, always you have to remember after writing two half reactions, if you go to the third step writing of overall reaction, you have to be very cautious and your brain should give you a alarm to check the number of electrons in both chemical reactions. Right here you have 2 electrons and here you have 2 electrons. So your road is very easy. If the number of electrons are same, and you can go to the third step directly. But if the number of electrons are not same, you have to equalize the number first and then go to the third step. Now listen to me. Zn solid, next same side, plus 2H plus aqueous plus 2 electron. This side all covered, the side of reactants. Now the side of products, this side, right? Zn2 plus aqueous plus H2 gas and plus 2 electrons. You can cut the 2 electrons both sides same, and you can write another step without the electrons, and that will be the overall reaction of this chemical cell, electrochemical cell. Okay, let's have a look in another chemical cell. Just you can play with this by changing the electrodes, right? So let me give you another option to play with this. Okay, then zinc and aluminium, and as an electrolyte we use same H2SO4. So now have a look, the same challenge, and you know how do you want to solve this. So don't worry, in order to make you familiar, I have prepared a long list of assignments, but if you do them and you will be get familiar, but it is must. But you are not sending me any feedback. Most of the students are not sending me any feedbacks. Some of are sending me, that's good, but I didn't get most assignments. I told you to send them through WhatsApp, but very few of you are sending me. But if you continue like this without sending, escaping, but after resuming the school, and you will be facing very serious consequences. Just keep in your mind and then send me your feedbacks, your assignments. Now look at this, zinc and aluminium. Now is the time. I told you the first step is decide which is anode and which is cathode. So in order to decide, you need and the activity series. Now take this zinc. Again, I just put a box here, square, and then aluminium above that. So now you think which is higher position that act as anode, which is lower position that act as cathode. So here in this case, aluminium is more reactive than zinc, so aluminium is the anode. So if aluminium is anode, means zinc will be cathode. So in the anode, you know what type of chemical reaction happens. That is no doubt anode oxidation, cathode reduction. Now let's go here. So what may happen? Writing chemical reactions. Right, have a look. I'm writing the oxidation first. Of reaction. Which one will be oxidized? Zinc or aluminium, right? You can decide now, right? No doubt, cathode, no any chemical reaction. Aluminium, anode, it will be oxidized. And now you decide, inside this cell, right, when I keep it, it was aluminium metal, but whenever the chemical reaction starts, it becomes aluminium 3 plus ions. So this is what happening there. Al solid turning into aluminium 3 plus. First reaction, but it is not completed. First we have to equalize the number of atoms. Second, you have to neutralize the charges. One aluminium, but this side you have 3 plus. You know what you want to do, and you can neutralize the plus by negative 3 plus. You have to add 3 electrons. Now it's neutralized. Next, reduction. You know, always H2SO4, H plus and SO4 2 minus is available, and H plus is a poor one. It is waiting to get electrons, so that is the one first obtain the electron. That is H plus aqueous, and here you can write H2 gas, always it produce H2 gas, right? And then you can see here 2 plus, so 2 electrons. The second equation also finished. Now the third step, writing overall reaction. And I told you, whenever I say or you think about the overall reaction, your brain should give you alarm to check the number of electrons. If you check the number of electrons, here 3 and here 2. So they are not equal. So before you write the equation, and you have to, what do you want to do? You have to equalize the number of electrons using simple mathematic rules. How can you do these things? So what is the common number between 3 and 2? And that is 6. So you have to make it 6, and here also you have to make it 6. But you can't multiply only the electrons, you have to multiply the entire equation. If you want to change the 3 into 6, you have to multiply this by 2. So you will rewrite this equation 2Al, and here 2Al3 plus 6 electrons. And here if you want to convert this 2 into 6, you have to multiply entire equation by 3. So 3 into 2, 6H plus ions, plus 3 into 2, 6 electrons, and 3 into 1, 3 H2 gas. Here 6, 6. Right. Now you have to add, this is the third equation and this is the fourth equation. You have to add these two equations, fourth and third. Look at this. Right. Let me use a different color marker. You can understand clearly. And this one and this one side. 2Al plus 6H plus 6 electrons and give you, and now this side and this, right? 2Al3 plus 3H2 gas plus 6 electrons from here. Now you can see 6 electrons cancel each other, and the remaining is the overall reaction. So one more chemical cell is here and another paper, but I don't do it on this. It will come to you in the form of assignment, and be ready and do it very quickly and repeatedly, and you will be the master of electrochemistry.